Let's see how to create PMOS common source amplifier with cascaded versions. That means here we are going to cascade the two PMOS common source amplifiers. So the gain will be high. So for that I'm just going to create the new project in LTSpice. Then we need to go to this component menu. So yeah, this is the component menu and I need to search for PMOS. And here is the PMOS 4, that is we are using the monolithic MOSFETs. So I'm just clicking the OK, and here we need to construct one PMOS common source amplifier. So for that initially we just want to name these terminals because we need not get confused about this PMOS. So okay, drain. So here always remember this is the drain and this is the gate and this is the source. So okay, I will just consider this. Okay, let's continue. This is the drain and here I need to just insert the source, and this is just we are naming out, and this is the gate. And always remember this is the base and which is connected to the source. So I just need to connect this base to the source. Yeah. Now the ID will be flowing from source to the drain. So that's why we need even a register here. Since it's a PMOS, we need to took the output at this terminal. So here I'm placing one input register. That means the yeah, this is not the input. Here we are giving the input, and this is the register across the voltage drop will occurs, and we need to take this voltage drop as the output. So this is basically the load or the RL register. And when to have the sources for our input that we need to providing to the gate, and we even need VDS. And since this is the PMOS, here is the P channel, and here we need to provide the electrons. So whenever the electrons come here, it will attract these holes. So in this P channel, more the number of holes means the current will flow. That means the current flow will be more. That's why we need to supply the negative voltage for this gate. So that's why I'm making this input as a sine wave with the okay. So we will just go to this advanced, and here is the sine wave, and we need to give the negative voltage. For example, -8 is the okay, minus 0.8. This is our offset. And the amplitude will be, let's say, 1 millivolt, and the frequency will be 2 kilohertz. So this is our input, and we need to connect this input to our gate. Okay, then this has to be connected to the ground. So I'm just placing a ground here, and I'm connecting this to the ground. We're done with the input part. Now we need to okay, we just change this to, instead of V1 we just change this to VGS. So this part is connected to the source. That's why the source has to be connected to the ground. And this is, we call this as a VDS. Okay, so we are connecting now the VDS. I need to connect here, and even I need to connect this to this register, and even I need to connect from here to here. Then we need to ground. Okay, so here this part is grounded, that is VGS, so the source part has to be grounded. So I need to ground the source part. Okay, I'm just moving this little bit this side. I need to connect this using the wires. Now we need to maintain this MOSFET in the saturation region. So let's say this is will be 1.6 volt. So in the saturation region, always remember the VGS, which has to be greater than VTP. That means VGS we are giving something minus 0.8, and we need to define the model for this MOSFET. That is, we need to define the what is the cutoff voltage and those things. So for that, okay, dot model, okay, dot model and PMOS. I need to write PMOS, PMOS, and PMOS, and I need to specify the two parameters, that is the okay, so Kp and VTO. So here I need to specify Kp equals to 200U and VTO equals to minus 0.6. So now I told the circuit that this PMOS and its characters here by providing this Kp and VTO. Now to maintain this in a saturation region, the VGS, which has to be greater than this VTO. So this minus 0.8, that is greater than this voltage. And even the VDS, that has to be greater than VGS minus VTP. So here VDS is 1.6 volt. So VGS, that is VGS, that is zero point 0.8. We need to take the modulus since it is the PMOS. So zero point 0.8 VGS minus VTP, that is this VTO. So that is 0.6. So 0.8 minus 0.6 will be 0.2. 0.2 is less than our VDS. That's why it is satisfying the saturation region. And here we need to, okay, I will just a little bit move this register down because we need not getting confused about this. So okay, now I think, yeah, so I'm just joining this too, and let's say this register 2k of register 2k. So this is my one circuit, that is the PMOS common source amplifier. So now I need to cascade this. Before cascading, we just once simulate this, and I need to see the output. So I'm doing the transient analysis. So stop time, it will be run for 10 milliseconds, and after 0, and here with the steps of 10. Okay, so now this is our circuit and this is that command, and we will see if I click the run, and we need to check the input. Okay, so this is my input. So this is 1 millivolt of input, and when we check the output, okay, so we forgot to give this length and the width of this PMOS. So let's say this is a 1 micro and this will be 100 micro. Then we just click run. Now if we see, this is the our, okay, we will just see from the beginning which is the input. This is our input. So our input is this green color line, and when we see the output, you can see this is amplified. So if we see the output voltage swing, that is from 792 to 800, that means it is like so basically 8. We are getting the gain of 8, but it is too less. So now what our idea is to connect another common source PMOS amplifier which is connected to this. That means we are cascading these two. That means we are providing the output of this amplifier to another amplifier which is of PMOS common source. So for that, simply we can just click this copy tool, and we can just copy these things and we can just paste it here. And these commands, that simulation command has to be only at the one time, so I'm deleting this one. And here, instead of providing this input, we need to provide the output of this circuit. So I'm just connecting a wire from this is the output. So from here to this input, that is the gate. So yeah, this VDS1 and this is and VGS. So this is our input and we connected the output of this circuit to this circuit and we are seeing the output here. So when I run this, you can see these two are this is the input and this is the output from this first amplifier. And now I connected this output to this input. And now if I check the output here, it is further increased. Now we can see the swing is from 740 to 800. That is the amplification or the yeah this is around 40. So we get the totally the our 1 millivolt becomes the 40 millivolt. That much of amplification it did. That means that much of increase this circuit will do. So this is called as the cascaded PMOS common source amplifier. Now let's check if we cascade another circuit then how this will going to behave. So for that I'm just going to copy this again, this circuit, and I'm just placing here. And now we need to give the input from this to this the gate. And if I run this circuit now, and okay, these things remains the same, and if I want to check the output here, okay, this is further increased. So this is zero point 0.8 and okay, so how much? This is from around 0.1 to 0.8. That is, we are getting around 0.8 volt, that is 800 millivolt. So but something this is not, the sine waves are not exactly the sine waves. Let this, the below side is little bit cropping or it is shifted. So I think we need to change this to 1.8 because this has to be remain in the saturation region. Now let's check it out. Okay, now it shifted something differently. So we just give this as 7.5, 1 point, okay. So now if we see it's almost amplified from, okay, so here we can see our input is only the 1 millivolt and we got the output of around 0.2 to 0.8. That means it's around 0.6 volt. That is 600 millivolt. That means we are getting the gain of 600. Yeah, that's a huge, right? So this is what the combination of these MOSFETs, that means the MOSFET circuits, cascaded of these MOSFET circuits. But make sure when we connect it like this, so we cannot able to increase the gain further by connecting like this because this has to be remain in saturation region. We need to follow this uh, like condition for all these kinds of amplifier circuit we use. All has to be in saturation region. I hope you understand the circuit. Thank you.